Hello everyone. So we will today we'll talk about regression. It is one of the most important topic, and you can expect several multiple choice as well as long answers in your exam. Um, so we'll start with the basic course outline. Here we will just introduce why we need regression, right? This regression is one of the supervised technique of machine learning, right? That can help you predict outcome, right, and as well as understand relationship between your data, right. We'll be actually talking about simple, multiple, and nonlinear regression. In simple linear regression, it basically talks about continuous outcome, right, for only one dependent variable, right. So, for example, given if you are actually trying to predict housing price, uh, the unit of uh, unit in terms of carpet area, right? So a square feet or whatever it is, and then its price, right? We'll talk about line of best fit and two key metrics: mean absolute error as well as root mean squared error. Both these topics are tested repeatedly in your exam. We'll also see some simple example, where given in a small data set, how you can compute mean absolute error as well as root mean square error. And we'll also talk about how these are different from each other, which is typically tested in your exam setup, in your objective or one of your long answers. Multiple linear regression, on the other hand side, right, could predict the outcome of a uh, your independent variable based on several dependent variables, which is typically the case, right? In real life, you have so many things deciding the outcome of anything that you are actually having in mind, right? For example, your housing price will not be dependent on your uh, carpet area, but it could be dependent on locality, city, you know, and many other attributes, right? That will actually give some indication of quality of construction, location, and many other factors. Uh, so we can see what is line of best fit in this particular scenario. And since we are talking about multiple, dependent variable, we'll talk that why, mean absolute error or root mean square error is not, right or easy to understand metric. So we'll introduce a new term that is actually called R square, and another term that we'll call adjusted R square. We'll not get into a lot of math behind it. We'll just simply introduce these two terms and we'll focus, how best to interpret it. And then actually, in multiple linear regression, your more than two variables could be, whenever your more than two variables are sort of, perfectly related with each other, there is a issue of multicollinearity. We'll talk about it, how to find it, and then we'll take actually, a project, and we'll actually sort of, analyze the California housing price data set, which is available in one of your libraries that you can either use in your RStudio or Python SDK. Then we'll actually quickly wrap up with nonlinear regression. So many a time, when your independent variable is not linearly, dependent on your dependent variables. Basically, when your relationship between your dependent and independent variable is not linear, then if you try and actually model it through simple or multiple linear regression, you'll not be able to do it, right? So you need to figure out, if there is a nonlinear relationship, could be say parabola, it could be, polynomial, or many others. So we'll actually talk about when to use it and certain steps before you can use it And then we'll actually sort of conclude by looking at your past year question paper for each of these categories, right? Thank you for joining. Subscribe and like the channel for next video, which will be actually about we'll be detailing about both simple as well as multiple and non-linear regression.